So, today you are going to learn about Newton's third law that states as when two bodies interact with each other, then they apply forces to one another that are equal in magnitude but opposite in direction. The third law of motion is also known as the action and reaction. So, in this we have to study about motion, forces, and simple mechanisms. First of all, you have to learn about what is momentum. The law of conservation of momentum states that if no outside force acts on a group of objects, the momentum of the whole group will never change. In this lab, this means that the sum of the momentum of vehicle 1 and vehicle 2 before the collision is equal to the sum of the vehicle 1 and vehicle 2 after the collision. The momentum of an object is obtained by multiplying the mass and the object of its velocity. As you know that the momentum is defined as mass into velocity, and its formula is m into v. So the difference in their mass and velocity, as well as the type of collision, will determine the change in velocity after the collision. Velocity has direction. For something moving in a straight line, or one way to show it is moving in a certain direction in by using arrows. An arrow pointing to the right, that means it is positive velocity, and if the arrow is in left direction, then it is a negative velocity. So before starting the experiment, you have to study about the objectives and the procedure of this experiment. You have to also put your data in the table. As you know, there's an option of table. Here it is. You have to put the vehicle mass, collision, vehicle mass, collision 1 and collision 2, vehicle 1 speed before and after, vehicle 1 direction of motion before, vehicle 1 momentum before. You have to put all these readings in this table. Also, you have to complete this journal in which there are only 4 questions. You have to answer these questions. So, in this, you have before starting the experiment, you have to first of all manage the readings. I have take 1,000 kilogram and 1,000 kilogram vehicle 1 and 2 mass. I predicted the speed that is 50 kilometer, and here I predicted the speed also 50. So I will think there when they collide, this move in left side, so it is negative, and its move in right side, so it's positive. So now, actual readings, that is I predicted that is 50 kilometer, but actual is 10 kilometer. I predicted the vehicle to speed that is 50 kilometer, but it is 50 kilometer as well, kilometer per hour. So direction of motion, I predicted that is the vehicle one direction is in left side, so it is it has negative velocity, or and as well as the vehicle two motion is I predicted on right side, that is positive, that has positive velocity. You have to fill this table like that. Vehicle mass, that is 1,000, vehicle vehicle 1 speed before, which I predicted is 50, after, what it is, 10. Direction of motion, I predicted that is in left side. Momentum, you have to find it by mass into speed. that is 1000 into 10, that is 10,000 momentum. As like now I have done plugin one, I again do it by changing its mass 30 3000 3000. I predicted the speed 10 kilometer 10 kilometer. It's when it's collide it moves in left and it's move in right. So, so the speed you will see the predicted at kilometer 10 kilometer per hour, so it is 10 kilometer. The mass is 3000. I predicted 10, so actual is also 10. That is in left side which I predicted left, and this is the momentum is 30,000. So this is the lab of motion force and simple machines in which you will study about motion forces, Newton's third law, and also about the momentum, law of conservation of momentum. Thanks.